Here we have another problem, part B of the problem 1.1, the book Introductory Quantum Mechanics, written by Richard L.Liboff. We have to find degrees of freedom and a set of good coordinates. The problem is part B, a bead constrained to move on a helix of constant pitch and constant radius. Here it is a bead constrained to move on a helix of constant pitch and a constant radius. We have to find degrees of freedom and a set of good coordinates. The figure is, this is the figure, and here is constant pitch and constant radius. That is, this is the distance from here to here is h. That is constant pitch. It does not expand or contract. Let us consider a spring. So it does not contract, neither expand, and this is the radius r, and it makes an angle theta. Okay, so the bead move, I have made in a simulation, so it moves like this. Okay, sorry, this is a simulation. The bead moves in this way. See it again. So the bead moves in this way. See, this pitch is constant, this radius is constant, only the angle theta is changing. This only angle theta, it moves in this way. So if you'll see in this plane, only the angle theta is changing. So it means it has only 1 degree of freedom. Nothing is changing. Neither r is changing, neither h is changing, neither the spring is contracting, neither the radius, see the radius is neither it is moving in this way, neither it contracts in this way, neither the radius is shortened, neither it is larger. So it moves in this fixed radius. So radius is not, so we need only one state. Only one state is changing, that is the angle theta. So the number of degrees of freedom, we have 1, and a set of good coordinate is angle theta. Now you will astonish here that the bead is constrained to move along 1D path in 3D space. Actually, it isn't in 3D. I have 3 arrows here. I have 3 arrows only to get my simulations in computer programming. Thus, though it doesn't sense here, forget about the systems, the arrows, and remove. Let us consider remove in your mind, remove from your mind. And so here particle has only one thing varying, that is angle theta. Every other things are constant, as we should focus on the definition of good coordinates or generalized coordinate system. The name generalized coordinate system, you should focus that what does generalized coordinate system means. It should be general. We at the moment forget about Cartesian, spherical, or polar coordinate system. In quantum systems we have n dimensions, so good coordinates work, or generalized coordinate system works well here in quantum systems. Therefore we take Hilbert space in quantum systems.